So section 2.1 introduced you to angles and arc length. And in particular, one of the big things that you picked up on in section 2.1 is that there's a different way to think about angles, and that's radians. So we're going to talk a little bit about radians and converting between radians and degrees. Now, the big thing there, well, I guess I should start this way, is try and understand what a radian is. A radian is the angle that you get if you take this radius of a circle and stretch it out along the edge of the circle. So if you take that radius, how far does it take you around? So this is an angle of 1 radian. Here's an angle of 2 radians, and then 3 radians. How many radians is it going to take to get exactly halfway across the circle? An angle of 180 degrees. How many radians would that be? Any guesses?
Pi.
Pi, exactly. So we'll start here. Pi radians equals 180 degrees. And that's great because we can use this to convert between radians and degrees if necessary. Because of this relationship, then if I divide both sides of this by 180 degrees, this is equivalent to pi over 180 is equal to 1. Or if I divide this by pi, then I get 180 degrees divided by pi equals 1. So these are two different names for the number 1. And why do I care about that? Well, because this allows me to convert between radians and degrees. So let's look at an example. Here's one that I took from my math lab. They want you to convert the angle 195 degrees to radians. Now, the important thing that you want to pay attention to when you're working through your assignments on my math lab is that sometimes they'll say, oh, we want an approximate answer. If they don't say they want an approximate answer, then the default is they want an exact answer. And that's what they're looking for here, is an exact answer in terms of pi. So got 195 degrees. 195 degrees, and I want to convert that to radians. So the trick is we're going to multiply by 1. And you've got to choose one of these two forms. But you want to cancel out units of degrees and end up with radians. So the units that you want to cancel have to go in the denominator. I can think of this as 195 over 1, if I like, and then I'll multiply by pi over 180. What's nice about this is you can see the units cancel out real nicely. There you go. You got rid of the units of degrees, and you're going to be left with something in radians. Now you can do this on your graphing calculator, etc. Now there's a couple tricks though that I'd like to show you. If I take 195 and multiply it by pi and divide by 180, I'm just going to get some decimal answer. And it's not going to look very good. But the problem asks you to keep your answer in units of pi. So we're just going to do the 195 divided by 180 part, and then we'll add in the pi when we're all done. Now it gives me something like this, and that's okay. But here's the trick that I want you to see. If you click the math button and then press enter twice, like this, it turns into a nice fraction. So the answer that they're going to be looking for in my math lab is going to be 13 over 12, and then we'll put in the pi. Or you could write it like this, 13 pi over 12, same thing. If you don't have access to a nice graphing calculator with this feature on it, then you can do the same kind of thing in Desmos. So it's just decimals.com/calculator. It'll ask you to sign in or something like that. But let's take a look here. If you type in 195 over 180, it's going to give you the decimal value, which looks like this. Okay, but if you want that as a fraction, if you just click this little circle here, it'll turn that into a fraction. I do want to point out that you can't, this won't work if I had it in units of pi. It's just going to give me that number and that's it. So if I did, say, let's see, 13 pi over 12, I just can't turn that into a fraction. It won't work. But if it was just 13 over 12, that would give me a decimal answer, or I can convert it to the fraction. So just a little trick there for you to help you come up with the nice fractions, because a lot of times these will be reduced in the lowest terms. Let's do one the other direction, converting from radians to degrees. So we'll call this example B. Example B. And what was it? It was 3.93. Thank you. 3.93. Now there's no units of pi here. It's just understood that it's built into this angle. What am I going to multiply by this time to get 2 degrees? Last time I was trying to get to radians. This time I want to get 2 degrees. 180 over pi. Perfect. 180 degrees over pi. And this just all has to be done on your calculator. So let me do it here. 3.93 times 180 divided by pi. Now pi is built into your graphing calculator, so you shouldn't ever have to type in the number pi as 3.1415, etc. Just hit the second key and then the up arrow right there. That gives you your symbol for pi. So second up arrow. And then they ask you to round it to the nearest hundredth of a degree. So 225.17. Be careful about the rounding. There is some tolerance built in, but I don't want you to see, I don't want to see you get this wrong because of a rounding error. You do get 3 chances at your problems on my math lab. So let's keep going. Those are a couple easy ones. I want to get to some of the harder stuff that you might see here. This one's kind of a good one. It says, estimate the angle to the nearest 1/2 radian. What on earth would that mean? Well, the angle that they're talking about starts out here as an angle in standard position and is going to rotate counterclockwise around to this terminal endpoint right here. We want to know roughly what angle that is. Well, it helps to keep in mind what a radian is. It's pi radians all the way across. 2 pi radians would take you all the way around. But let's just keep an eye out. There's 1, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. Now it's asking us to estimate this to the nearest 1/2 radian. So what would that be? What would you guess? Nobody? So the angle's about right there.
5.5.
Yeah. Thanks, Alexis. 5.5. And that's it. About 5.5. So type in 5.5 and that's all you have to do for that one. Now there's a couple other types of problems that we dealt with in this section. One of them was this one, or is a problem that deals with this one, and that is S equals R times theta. So example C, S equals R times theta. There's one thing that's important about this. Let me remind you what that stands for first. This is your arc length. Arc length, R is the radius, and theta is your angle. But what's the important thing about theta? You remember?
Has to be in radians.
Yeah, in radians. So this is me screaming this into your notes. Theta has to be in radians. So when you're working these problems, if you're given an angle theta, make sure that it's in radians. If not, convert to radians first. Or when you're done working your problem, if they give you, say, S and R, and you have to figure out theta, keep in mind that your answer is in radians. Let's take a look at this one. So we're asked to find theta when we've got a length of arc, which is 16 feet, and a circle of radius 30 feet. So let's think about what that might look like. So something like this, maybe. So you got a length of arc, which is 30 feet, and a radius, which is 16 feet. So 16 feet here, and intersects an angle such that the length of arc here is 30 feet. So that's a picture of what's going on. We need to figure out what theta is. So S is 30 equals 16 times theta. So you're going to get something a little bit more than 2 radians. Divide both sides by 16, 30 over 16 reduces to 15 over 8. Now, actually, I guess not quite 2 radians. Equals theta. And there's your answer. Now, if you needed to, you could convert this to degrees. You'd simply multiply that by 180 over pi. So 15 divided by 8 gives me that. Hit the times key, times 180 divided by pi. There you go, about 107 degrees, which is exactly down to the nearest thousandth what I drew. LOL. All right. One last one that I want to do here, and it's kind of a cool one. It comes from our S equals R times theta relationship. And actually, let's see, it's R times omega. So your linear velocity is the radius times your angular velocity. Angular velocity is how fast your angle is changing. Linear velocity would be like your speed. So this would be how fast your tire is turning. That's how fast you're going forward or backwards. So let's look at this last one. I would suggest that you maybe even start with these, these last set of problems. This should be problems like 34 and 35 on your homework. Says the diameter of each wheel of a bicycle is 27 inches. If you're traveling at a speed of 25 miles per hour, how many revolutions per minute are the wheels turning? So, okay, let me kind of put that a little bit more front and center here. Just for convenience, I'm going to change this to 28, just so that we have a little bit more of an even number to work with. So let's write down 2 things. First of all, the diameter of this. So the diameter is, we'll call it 28 inches. And then our velocity is 25 miles per hour. Okay, so if you start looking at our formula, V, R, and omega, it looks like a W. If you want to call it a W, that's fine. It's really an omega, a lowercase omega. Our velocity is in miles per hour. That's going to be a little bit of a problem. We'll come back to that in a minute. Here we've got a radius, well, I don't know. The diameter is 28 inches. What's the radius?
14.
Good. Radius is 14 inches. But we're going to run into a problem if we try and finish solving this with such mixed up units. You're going to have miles here and inches here. They both need to be the same. So it doesn't matter which one you choose, but you're going to have to convert one unit to the other. So I'm going to choose to convert inches to miles. And it's going to be a result of multiplying by 1 like we did earlier. 14 inches times some form of 1. Well, let's convert inches to feet first. So if I want inches to cancel out and feet to be left, I'll put inches on the bottom and feet in the numerator. What's the relationship between feet and inches?
12 inches for every foot.
Good. So 1 foot is 12 inches. And then I'm going to help you convert from feet to miles. Now, if there's a runner out there, I'm sure you know how many feet in a mile.
5,280.
Way to go, Reagan. So there's 5,280 feet in 1 mile. And if you look at how this is set up, units of inches will cancel because you got here on the top and here in the bottom. And that'll leave you with units of feet. But then we're not happy with units of feet either. We're going to cancel out units of feet and end up with units of miles. So what it'll end up as is 14 over 12 times 5,280. That's going to be your distance in miles. So it's going to be really small, right? It's going to be a really small number because this is going to be like 60 or 70,000, somewhere in there. 14 divided by it, it's going to be really small. It's a really small chunk of a mile, but that's okay. Let's put that in here. And in fact, maybe it's helpful to have a decimal value there. 14 divided by parentheses, 14 divided by parentheses 12 times 5,280. Ooh, do you know what that negative exponent means? It means times 10 to the negative 4th power. Realistically, that means 3 zeros and then the 2. So 0.00022 1, we'll call it. All right, almost done. Let's see, 25 equals 0.000221 times W. How do you solve for W?
25.0.
Yes, thank you. So I'm just going to use this number because it's already here on my calculator. And the way you can do that is you can hit 25 divided by my previous answer. And my previous answer is conveniently stored for me in a couple places. If you hit the second key and then the negative key here, you'll get to your previous answer, or you can just do this. Just go up here, press the enter key, and it'll bring it down. Either way, you're going to get this, which is going to be 113,842.8571, etc. That's omega. But if you remember, that's going to be how much change you get per hour. So there's a couple things wrong with that. The problem was asking you for revolutions per minute. So if I wanted to convert this to minutes, or angles per minutes, I'm again going to play this game of multiplying by 1. There's 1 hour in 60 minutes. So just divide this by 60, and you get 1885.71 is, or 271 radians per minute. I'd be happy to tell you done, but we only got one more thing to do. Let me pause here for a second. Are you okay with what we've got here?
Yes.
One last little thing to discuss. All right. That last little thing to discuss is the fact that they want your answer in revolutions per minute. So let me highlight that down here. Revolutions per minute. Not radians per minute, revolutions per minute. And here's the thing. 1 revolution is 2 pi radians. That's the thing to know to finish this one up. So in particular, for this problem, I've got 1885 radians per minute. And I'm going to play this game of multiplying by 1 last time. We're going to use this relationship right here. What should be in the numerator? What should be in the denominator? Your chance to be a mathematical hero or heroine. What's going to go in the numerator?
1 revolution.
1 revolution. And then in the denominator?
2
Radian.
radians.
2 pi radians. And I'm not even going to write radians. It's just 2 pi. It's understood to be in radians. Yeah, maybe I should. And cool. That cancels out. So basically, you just got to divide this by 2 pi. And that'll do it. So divide by parentheses 2 pi. Parentheses 2 and then pi. And that's your answer. 300.12 revolutions per minute. That's pretty cool. That means your tire is turning about 5 times every second is what that's equating to. Neat. Okay. That'll do it for your little primer on section 2.1. Let me stop the video here, unless there's some more questions, and I'll get you in your breakout rooms. All good?